In the last episode, I designed and built a welding fixture table, kicked a tire, checked how flat the table really is, and shoot a spray bottle. By the way, you can now get the plans and DXF files for this specific welding fixture table, as well as 107 other models of different sizes, metric and imperial. Okay, today I'm gonna try the famous Weld a Square challenge. Okay, it's not as famous as the Ice Bucket challenge. Not sure it's our most glorious moment in humanity. Well, at least they were not eating Tide Pods. Anyway, Jason from Fireball Tools challenged different companies to weld a simple square made out of tubing, and unfortunately, they all failed to respect the drawing specifications. So I'm gonna try it for myself and see if I can produce such a part using my own fixture table and hope to meet the tight tolerances, or fail trying. But first, and because in the previous episode I mainly focused on building the table, I'll spend a bit of time on the accessories before taking on the challenge, and we will start with one of the favorite subjects of this channel, you guessed it, clamps. Okay, hear me out, welding clamps are awesome, but expensive. So what if I could build myself a set of different type of clamps, only using flat bars and laser cut parts? And yep, this is what I'm trying to do with these parts. Okay, I know, for the fixture table, I ban any sort of machining, basing myself on the fact that only a few of you, some rare lucky ones, might have a milling machine or a lathe. And here I'm making the screws for the clamps, and since I include in the accessories package a detailed plan to machine these screws, and because these clamps will be mine for probably the rest of my life, I went with the machine version. But don't worry guys, after I'm done machining, I'll show you two different options to make the screws with the swivel foot. Here I'm making the section that goes inside the foot, which should be kind of a ball. I did the rough cut using the chamfer tool and rounded the corners with the file. Now for the foot itself. Here I machine a small lip. It's about 1/8 of an inch long. You'll see in a minute why we need this lip for. And this is why I love so much the fixture table, and I think if you're into welding, you should have one too, even if it's as small as a 2x3. Because by the way, 95% of what I'm building could have been done on a 2x3. The only, and I mean it, the only downside of this table is, surprisingly, the holes. Anything that can go through them will go through them. You just have to look away for a second and it's already gone. Anyway, here I improvise a mini J to hammer the small top lip I just machined, locking the foot to the screw. Okay, this is not the prettiest one, but the range of motion is quite good. Once all 10 were done, it was time to install the handle. It can be made from a small rod that you tack both ends, or from a bolt. Okay, as I said, maybe you don't have a lathe, so one of the options is to use some nuts and bolts. First, using a Porsman lathe, you're gonna round up the head of the bolt. Then, using a chunk of aluminum as a backing plate, you will plug the washer's hole. Followed by oversizing the hole from a 1/2 inch nut using a press drill. That's why I own a freaking milling machine. Then you tack everything together. And voila. And voila.
What? Yeah, that's funny. There we go.
Okay, this one is fucking ugly, but hey, that's a way. And I'm sure you're gonna make yours way prettier than this one, because this little guy is directly going in the trash bin. But I do have another, much sexier option for you, and it's by using the screw from an old C-clamp. And luckily, this one is bent, so I won't mind cutting it. And that could be a great option because you might find some real cheap C-clamps at your hardware store. Ta-da! As simple as that. So I just made a mini version of the clamp included in the accessories package. Yeah, I know, these might be on the big side of things. As soon as I made the first one, I realized how big they were. And there's something about them that I don't like. They work, but I don't like how crooked the screw is. Maybe it's coming from the half-inch plate bending.
So at the middle is about 1/32 of curvature, so not much, but...
But yes, I have an idea on how to solve the crooked screw. Okay, you understood that the issue was not coming from the half-inch plate bending, but from all the existing gaps, and I'm talking the pin with the table, the sliding plate with the flat bar, and so on. To counter that, I welded the sliding plate at a slight angle. Oh, much better. Also, if you're a lucky owner of an oxyacetylene torch kit, you could pre-bend the plate. Works super well. Actually, I think I prefer this method. I know we're already 6 minutes 9 seconds into this video, and there's no weld a square challenge in sight. But quickly about the clamps, I just want to show you that I made a pusher version. Not sure when I'm gonna need these, but you never know. And lastly, I made these, and I'm glad I did. Okay, to be fair, I did work a few times with these, and they're not as sturdy as this Big Bertha, which takes forever to open and close.
One eternity later.
Plus, I added 2 head bumps, so you can use the clamp in push or pull mode. One has an opening of 15 inches, and the other one is
21¼
compared to the Big Bertha, which is only
12 inch.
To conclude with the clamps and to give you a starting point, if you're looking to build your own set, this is what I did. I made 2 C-clamps, 3 bent versions, 2 adjustables, 2 pushers, a real small one that I bought, super useful for small stuff, and my own mini version. Right, in part 1 we determined that the gap between the pin and the fence, the pin and the table, and how accurate you build a fence will give you about plus or minus 1/32 of precision. We also concluded that it wasn't such a big deal since, to set the distance, we are using an adjustable fence. But I'm worried that this plus and minus 1/32 will have an impact on the squareness on the thing we're welding. And to validate my point, I'm using a plate that all 4 sides were machined with a CNC milling machine. So it's pretty much the only thing in my shop that I can assume it's square-ish.
5, no. Oh. No, not even 5.
Okay, I was trying to make a point here, but apparently I got lucky, because even a 5/1000 shim won't go through. But because I'm a trained actor, let's roll the movie magic and pretend that one side is out of square.
Oh my god! That's 25 thousandths of an inch!
I know. That was good. Yeah, I'm available right now for small rows, so let me know in my DM. Anyway, so to solve the potential lack of precision, I come up with this. It's a simple rod, welded to a flat bar, I know. But it's the equivalent of the machine pin, but again, without using a lathe. So yeah, I know that the machine pins on a fixture tables are all loosey-goosey, and even with the big flat bar at the back, mine is too. But by using a long nose clamp, now this thing is solid as a rock. And by reducing the number of parts, we should reduce the amount of play, thus being more square and precise.
That's 5,000.
Well, I mean, I won't be able to beat the test I just did with the fences, but at least we're getting the same result.
Nope.
And also, these are only 5/8 of an inch wide, so they will be really handy when you need to put a stopper in a tight spot. Someone who bought the plans reached out to me because he was extremely surprised how much bigger I had to make the holes in the DXF files to fit a 5/8 pin. And here I'm checking a hole that I used a few times, so I considered it of being kinda loose, but it's only 3 thou over, even though I put in the CAD a gap more than 3 times that. So don't forget, before sending anything to be laser cut, do the testing plate and check the fit, like I did in episode 1. Maybe your supplier will have a better laser machine than mine, or yeah, maybe it's the opposite. Regardless, the cut precision may vary from a supplier to another. So for my table, I choose to have the holes smaller and closer to that 5/8 pin dimension, thus being more accurate, but it also means that a few holes are pretty tight. So I put together a pin's pry bar with bits and pieces laying around the shop. Oh, and yeah, don't use plasma. It's not precise. The holes won't be round. Just don't use plasma, okay? Okay, we crossed the 10-minute mark, and I know there's still no welded square, but in episode 1, I showed you the super square, and I forgot to introduce to you the super mini square. Pretty much the same shit, but smaller. Using a backing L-shaped plate, you can easily set 2 tubes, perfectly flush, perfectly squared. And you have 2 sets of holes, so you can offset the L-shaped plate to fit a smaller tube. I know, it's so clever. The more I've been working with this fence system, the more I realize that they're just like Legos. And I love it because the combinations are infinite. The last accessories I want to talk about is the adjustable swivel fence. At first glance, you might think that you only can cover plus and minus 45 degrees with it. But in fact, by flipping 90 degree the fence, this swivel clamp will cover any angles your project will need. To give you an idea, I simulated a fixture setup using my pipe bender's frame that I featured in a video series a few years ago. Also, combined with a tower, it could be used to set a part at an angle. So let's start with the example where the part needs to be more than 55 degrees from the table. Okay, what if the part needs to be below 45 degrees? Oh, you'll see that the swivel fence has a trick up its sleeve. And I designed it so that you'll use the back face of the fence, and that the part will rest on the 2 L-shaped stiffeners.
Nice.
Okay, we're almost there, but I need some practice before doing the challenge, and since I need a ballast box on my tractor, let's use the counterweight of the quite popular snow roller. By the way, this is the best project ever. Works super good, costs nothing to make, took a weekend to build, 2 weeks to edit, and now it's the 2nd most viewed video on my channel. Okay, while we're watching Viny from the past uncoupling the snow roller, we need to talk. Guys, I need your help, because I want to know what is the next tool you wish you could get the plans and the Excel files for. I got a few ideas, but I want to hear it from you. Alright, let me know down below. And let's go back to the snow roller, because I think I should do a follow-up with the 200 people who commented that the snow roller will build up so much ice that it's gonna be a complete nightmare during spring. So yeah, it's fine. Anyway, now I set the jig, put down some 1/4-inch shims, and was ready to build the ballast frame. If only that last piece could fit in. Okay, I'm even more in love with this table. Because I knew my Benza couldn't do perfect 45 degrees cut, but never thought to that extent. And it's clear as day why the parts don't fit in the jig, even though they're at the right length. Something I wouldn't picked up if it wasn't for the jig. After a bit of fiddling, I was able to fit the last part and clamp everything down. I started by tacking all 4 corners and then went to town on the welding, which I think came out looking pretty good.
That's nice. Nice! Damn, I love this thing! Woo!
Then I check for flatness. Not that this particular piece needs to be flat, but has a practice frame. I want to see how bad it is.
16. Nope. It's like 11. 11 can go all the way all around.
Wait, what? 11 thousandths? What? That is dang good. Okay. After welding the center post using the super square and slapping a bit of paint on the frame, it was time to install the counterweight. Okay, now for the real deal. First, the plan calls for a square frame made out of 2x2 tubings, which apparently I don't have, but that's okay, that's fine. It's just to validate the outside dimensions, and to be frank, at the end, this frame will probably end up in the trash container anyway. And I'm pretty sure the plan calls for new tubings too, but they're not. But does it really matter? And I wish I could use tubings of the same wall thicknesses, but this is what I've got, so who cares? Okay, the maximum outer dimensions are 20 by 20 1/4, and the tolerance is +0, -116. So I'll set the fences exactly at the limit distance. This way, the frame can only be smaller, thus respecting the tolerances. Once again, the jig operated its magic and showed that some parts were too long. After cutting slices as thin as Doritos chips, the fourth piece was in place.
Ah, man.
Same ritual as the practice frame, tacking, then welding. Then I flip the frame, weld the other side, and grind it, like the plan called for. First, I check for squareness.
Yeah, there's something crooked. 11's not going in here, but it is here, so.
Wait, what? 11 thousandths? What? That is dang good. Okay. Okay, it's square, but right away I spotted a bigger problem, one that could fail the frame.
Fuck you.
But to make sure I'll get the best results, and since we know that my table has low spots of 10 to 20 thou around the edges, let's head to where I'm working and use some high-tech equipments. And unfortunately, I won't be able to use the CMM because this marvelous machine can only handle parts up to 16 by 16. Instead, I'm gonna use the more rudimentary surface plate. I weighted down the rocking corner and used this side to set the 0. Then I went to the opposite side, reached 0 on the dial indicator, then checked the number on the height indicator, which is for one of the tubing about 34 and for the other one 45. Part is still good since the plan required a maximum of 62 thousandths of twist, and I'm convinced that it's my lack of practice with the fixture table that caused the twist. Cause remember on that first practice frame, it was just 11 thousandths. Moving on, let's check the outside dimensions. So I'll check the top and bottom section, but only show you the worst of the two. Okay, here I think we need to pause and zoom in. So we see that we're at 20, then 200, and 17. And we were allowed a max 0 and minus 62 thousandths. Oh, yeah, that's right. For all of you non-American that have absolutely no clue of what I'm talking about, because, yeah, lucky for you, you're using the smarter system. The part is still good, because we're in between the tolerances. Yay! And for the width, the smallest section was at 19.985 inches. Only 50 thou under 12 inches? And that's insane to be able to produce such a precise part with only a fixture table and a measuring tape.
There you go. I passed.
Okay, now I think there's only one thing left to do. Are you out of your mind? You know it, when it comes to steel, I have a big parting problem. Because throwing a perfectly good tubing frame, yeah right. Alright, I'm gonna see you on the next one.